is Space Day, as you know, and we have our guest expert here, Margaret Carter. Hello, Margaret. Thank you so much for joining us today.
I'm happy to be here.
Awesome. So Margaret's an instructor at Lambton College, and she's also worked as a researcher with the Canadian Space Agency and NASA as well. So on Space Day, campers are using their imaginations to build spaceships and simulating the galaxy with Galaxy Play-Doh, and they'll also be building a model of the solar system, which is really cool. So before we get to some of the questions from the campers, Margaret, can you tell us a bit more about what you do and maybe what it was like to be a researcher with Canadian Space Agency?
Sure. The project I was working with had to do with bubble formation. A lot of the ways that bubbles behave, if you've looked at a sink full of suds, how many people have done that? Sink full of soap bubbles? And you see they all disappear after a while, right? They pop. Well, that happens because of gravity. So we wanted to take those bubbles up into space and see how differently they would behave. So I was making a foam, kind of like the foam you see on the top of your bubbles, and making it harden. And then we brought it back and took a look at what was different about those bubbles. So I did go up into not the space station, but a plane that was specially modified to fly like a roller coaster. How many people have been on roller coasters? Kind of scary, isn't it? You go up and down and up and down. Well, we did that in a plane. We went up and down 10,000 feet. So it was it was pretty extreme. And on the upward, I weighed twice as much as I normally do. And on the downward, I was weightless. So I was in zero gravity. And that's when we did our experiments. And on one day, we did that 40 times. So up and down, like the longest, biggest roller coaster you've ever been on. How many people would like to do that? Yeah, a few people? The brave ones. Oh, more and more. Good for you. So that was the fun part.
Awesome. Yeah, I wouldn't mind trying that either. So maybe we can go to our first question now. Let's go to Ancaster. If there's a question ready in Ancaster for Margaret.
Go ahead.
So my question is, when is it likely for a colony to be established on the celestial body, for example, the moon or Mars?
When did you say? I missed the first part. It cut out.
When is it likely?
Okay. I think it's a long way away, although it's possible that you might see it in your lifetimes. That kind of project would be very, very expensive. And these days, funding to the space agencies have decreased from what it used to be. I think what we need is a motive. In all of the really active time, when men were going to the moon and we were talking about going to the Mars, there was a competition between Russia and the US, and they each wanted to be the first to do each of these things. That has kind of decreased, and we don't have a motive in terms of a need to find new resources or materials to go up there. So that's going to have to come in place before they actually commit to spending the money to going up there. But once they have that motive, I think it'll happen pretty quickly. I think it'll probably take 10 to 20 years before they have something up there. Good question.
Yeah, wow, good question. Thanks. So let's go to London. Is there a camper with a question there? Yeah, hi.
Go ahead.
Hello.
Hi.
My question is, how big is the sun?
Well, that's a really good question. It's very, very, very large. It's a whole lot larger than the Earth. But as for numbers, I don't know. I don't have a good memory for keeping numbers like that. But you know what? I bet you could Google it as soon as we're done here.
Definitely. Thanks, Margaret. So I'm looking at the questions coming in on Twitter, and there's one from Woodstock. Hi, Woodstock. They want to know, how much power does it take to fly a rocket?
It takes a lot of power. It takes an enormous amount of power. The shuttles that go up to the space station, the main shuttle is shaped like an airplane, and you've probably seen pictures of it. If you've seen it launched, you'll notice that there's two other pieces that you don't normally see with that shuttle, and they're almost as big as the shuttle itself. So 2 times as big as that shuttle piece, and they're filled with fuel, and that fuel has a tremendous amount of energy. What the energy has to do is overcome and then go further than that, the force of the Earth on that plane. So you can imagine how heavy it is. So that fuel has to overcome whatever pull the Earth is having on that shuttle, and then produce then again as much energy to create the acceleration that you see, which is pretty significant. So it's a lot of fuel.
Yeah.
A lot of.
All right, let's go back to Ancaster. Is there another question for Margaret in Ancaster?
Yes, there is.
Awesome.
Great. Go ahead.
How rocket Blastoff? How rocket Blastoff?
How does a rocket blast off is the question?
Yeah. Was that it? The audio was cutting out a little bit.
Yeah.
The audio. Yeah, the rocket blasts off by those two fuel things that I was talking about. They can be various things, but one thing that they use is just hydrogen and oxygen, and those are gases normally, but they liquefy them. So those rocket pieces are full of liquid hydrogen on one side and oxygen on the other. And all they have to do is channel those, take a tiny little bit in some tubing out of each of those cylinders and join the hydrogen and oxygen together. And there's an immediate and very energetic reaction that creates water as a gas. And that water goes shooting out the back. If you've seen the takeoff, you see those white plumes. It's the same thing that you see from airplane trails in the sky. That's water vapor. And that's what pushes the rocket away from the Earth. So I'm not sure if that's what you were asking, but you can follow up if not.
All right. Yeah, so I see lots of campers in London. Is there another question for Margaret there?
Go ahead.
How much time does it get? How much time does it get to the light to get to the coldest planet? How much minutes, I mean?
Minutes to get where?
To get to the coldest planet.
Oh, the closest planet.
Closest.
Yeah, Neptune.
You know, that's something that can change to get to Neptune. And if you can imagine, if you were to bicycle to your friend's house, how far away is that? How long do you think it would take you to bicycle?
To your friend's house. Maybe 15 minutes.
15 minutes? And how long would it take if your mom took you in the car?
5 minutes.
It takes a few minutes, wouldn't it? 5 minutes? So how long it takes us to get anywhere depends on how quickly we go. The car is a lot faster than the bicycle. And when it comes down to rockets, that's important because the faster we go, the more fuel we use. So typically we go fairly slowly. We want to use as little fuel as possible because we have to carry all that fuel with us. So we don't have a one number answer for that question. It's a good one. It's a complicated answer. So it depends on how fast you go, and the faster you go, the more fuel you use. So we tend to go slowly.
Okay. Thank you. Woodstock has sort of a related question. They want to know, how long is it from Earth to space? So I guess getting out of the atmosphere.
That's a good question, and it is a related question. It's the same answer. It depends on how quickly we want to go there. Space, I guess, would be defined as leaving the solar system. So you'd have to go past Pluto. I guess it's not a planet anymore, but it's still part of our solar system. That would take a long time, and because we'd need to go slowly, unless we find some way to collect energy as we go. I was watching TV last night, actually, and they were talking about using dark matter. I don't know if anyone's heard about dark matter, but it's a way that we might be able to find energy as we go. And then we could go as fast as we want. But right now, we are limited by how much fuel we can take with us. So we have to go slowly. It would take many, many, many months.
Mm-hmm. But using dark matter, that sounds like a really neat possibility. That's cool.
Yeah. Apparently 70% of the universe is dark matter.
Oh, wow.
There's lots of it.
So it would make a good fuel source. That's awesome.
Exactly. Yeah. Yeah. Even here on Earth.
Yeah.
No more debates for windmills.
Yeah. Let's go for our third round of questions to Ancaster again. Is there a question ready for Margaret and Ancaster?
Yeah.
What does it feel like to be on the moon?
Well, it would feel very, very strange because you know what? The first thing you'd notice is that the force of gravity is only 2/3 what it is on Earth. So it would feel very similar to being underwater. If you jump underwater, it takes longer for you to come back down, right? You have that feeling of floating. You still weigh something in the water, but you weigh a lot less. So the closest thing that you've probably experienced that would be like being on the moon is being underwater, moving around. Everything's a little bit more slow, and that would be the case in the moon too. You'd be able to jump really high. Yeah.
Good question. Thanks. So let's go back to London. We can take another question from London.
Why does the Earth move and will not busy?
That's a really good question. The Earth has to move because if it didn't, it would get sucked into the sun. So it's like, have you ever taken a skipping rope and swung it around on the ground or around your head? And if you stop swinging, what happens to the rope? It wraps itself around you, doesn't it? And that's what the Earth would do if it stopped spinning, if it stopped moving around the sun. The reason we're not dizzy is because it's happening so in such a big circle that we can't tell that it's a circle. To us, it's like a straight line. So if you were making a circle from if you were out on a boat and you were making a circle that was like 3 miles big, you wouldn't really know it was a circle. It would feel just like you were on a boat. So that's why we don't get dizzy. But it's a good question.
Yeah, good question. So going back to Twitter, question from Woodstock. They want to know, why is there no air in space?
That's a good question. That's a good question because space has no gravity. And as much as we think air is weightless, it's not. It does have weight, and it needs gravity to be collected. Gravity grabs onto air just the same way it grabs onto us. So if there's no gravity in space, if there's no object to create gravity, then the air won't stay in place. It's a good question.
Yeah. Okay, so we're coming to an end for our time with Margaret, but let's go to Ancaster for another question. And then maybe we'll finish in London.
How does the solar system spin around? How does the solar system spin around?
Good question. It's spinning because of leftover energy from the Big Bang. Does everyone know what the Big Bang is? How many people watch that show? Anyone? I love that show. The Big Bang is the source of a lot of energy in our universe, and it's what created everything to be moving around. It's what started everything flying. And that leftover energy is why everything in the universe is moving. It's moving in circles, and it's moving out from a center point. So it's leftover energy from some event that started everything moving. It's an excellent question.
Yeah, cool. So let's go to our last question in London.
How are stars created or made?
I was sorry.
How are stars made?
Oh, stars are made when a certain amount of them. Remember, I talked about gravity and the fact that it grabs onto air. If you get some stuff coming together in a lump, now it's got a little bit of gravity, and another little piece of something will get sucked onto it, just like things are collected on the Earth, like air and meteors and stuff like that. So bit by bit, more and more and more stuff collects. And then when it gets really big, it starts collecting from way, way away. It starts collecting debris and other things from further and further away. And then it gets really, really massive. And now you have a sun. It's a good question.
Yeah, cool. All right, so that's all the time we have for our call with Margaret Carter today. Thank you so much, Margaret, for calling in and telling us a bit more about.
I love meeting you all. You're great.
Pardon?
You guys are great. I love meeting you all.
Yeah, and really good questions as well. Thank you.
Bye.